Rules for implication. We shall now learn an elimination rule as well as an introduction rule for implication. These rules are the following. Implication elimination rule. If we have derived A implies B and we have derived A, then we can derive B according to this rule. The implication introduction rule says if we can derive B under the assumption of A, then we can derive A implies B and eliminate the temporary assumption A. Learning to use these rules requires a little practice. However, let us first look at these rules a bit more carefully. The content of the implication elimination rule is that if we have derived both A and A implies B, then we can conclude B. This is how we think of implication A implies B. We even read A implies B as if A then B. So if we have A, we should indeed conclude B. What about the implication introduction rule? This rule says that if we can derive B under the assumption A, then we may conclude A implies B without any assumptions. This rule establishes a tight relationship between derivability and implication and corresponds to the intuition that implication is a formalization of logical consequence. Here is an example of the use of the implication elimination rule. We derive C from A and left parenthesis A or B right parenthesis implies C. We prepare ourselves to using the implication elimination rule. For this to work, we have to derive A or B from A. But this can be done by means of the disjunction introduction rule. Here is an example of the use of the implication introduction rule. We derive A implies C from the assumptions A implies B and B implies C. First, we prepare ourselves for an application of the implication introduction rule. So we make the temporary assumption A and try to derive C. Our assumption A arrows B together with the temporary assumption A immediately gives B. From this and the other assumption B arrows C, we get C. And we are done. Derivation of A arrows A. This is again a somewhat singular case. Let us again remark that proving such an extreme case as A implies A may seem totally unnecessary, but it is good to check, because these extremely short deductions are building blocks of bigger ones. If this is a simple case, it should be easy for us. The formula A is both the assumption and conclusion of this one-sentence derivation. Now the assumption A can be eliminated to derive A arrows A. And we have proved A implies A without any assumptions. Rules for equivalence. Dealing with equivalence is like dealing with two implications at the same time. The equivalence elimination rules are: if we have derived A if and only if B, and we have derived also A, we can derive b. And on the other hand, if we have derived a if and only if b, and we have derived b, then we can derive a. The equivalence introduction rule says if we have a derivation of b from a and a derivation of a from b, then we can derive a if and only if b, and at the same time eliminate the temporary assumptions a and b. What is behind the rules of the equivalence connective? The equivalence elimination rule says that if we can derive both a and a if and only if b, then we can conclude b. The intuition behind should be obvious. After all, a if and only if b says that a and b are, quote, equivalent, unquote. So if we have derived a, we should accept b too, and vice versa. As to the equivalence introduction rule, it says that if we can derive b under the assumption a, and also a under the assumption b, then we may conclude a if and only if b without any assumptions. The derivability of a and b from each other is interpreted as the equivalence of a and b, that is, as a if and only if b. As an example of the equivalence elimination rule, we derive c from a and left parenthesis a or b right parenthesis if and only if c. First we prepare the ground for an application of the equivalence elimination rule. For this to work, we have to somehow deduce a or b. So what do we have? What can we use to deduce a or b? One of our assumptions is a, but of course we can deduce a or b from a. This is just disjunction introduction rule. So we are ready. As an example of the equivalence introduction rule, we derive a if and only if c from the assumptions a if and only if b and b if and only if c. First, we set the stage for an application of equivalence introduction rule. We then make the temporary assumption a, trying to derive c, and at the same time we make the temporary assumption c, trying to derive a. We now use the assumed equivalences a if and only if b and b if and only if c, applying successively the equivalence elimination rule, getting c on the left and a on the right. We have derived c from a and a from c. We are done.